previous application which was built to predict the COVID-19 based on the posterior anterior lung X-ray. So the user, so this is a base home application where we have inputted a button to the user to go to the prediction where they could upload the X-ray image and send it to for the neural network to predict whether the patient is COVID-19 or not. So let's click on the button and upload one of the image of the COVID-19 which we have downloaded from the open source dataset from the one of their GitHub repository, which will be available in our project description. So this is a file where the user needs to input. So this is one of the image which has a COVID-19 from Singapore. So I'll just open the image. So this button would internally invoke the neural network trained model and predict whether the user is whether the given X-ray images of COVID-19 patient or not. So this is the image, and our network has predicted it as positive. So in order to move back to the user, we have made it to have a new prediction based on the predict new, which would be going back to the previous page which the user has visited. So now let's go back and test if the normal X-ray image is predicted correctly or not. So now let's take the image of the person who is of the normal one. So the class A which is there here is of the dataset of the COVID-19 patients, and class B is of non-COVID patients. So this we have taken from one of the Kaggle datasets where the competition was for predicting the pneumonial patients and normal patients. So on submit, let's see what the model will be predicting. So it has predicted that the X-ray is of negative COVID, so that's how it's predicting for the model. So while training the model, we have only considered the normal patients and COVID-19 patients images, but we know that COVID-19 would come again into one of the pneumonial types, whether it's SARS or MERS, other kinds of viral pneumonial or bacterial infections. So if we have a proper data set of what the other kinds of images are, we can retrain the model and segregate the appropriate model. So our training, so we could get an images of 115 posterior anterior images from the GitHub, so from which we have created the respective model, trained the model, and we took around 300 images of normal X-rays, and we trained that as a class B sets. So our training accuracy of the model was around 99.7%. So the accuracy which I have mentioned is on the validation dataset. So we have splitted the entire images into 90% for training and 10% for cross validation. So the cross validation accuracy was 97.7, and the model confusion matrix, the precision of the model and the F1 score is around 0.98 for the negative class, which means the non-COVID patients, and for the COVID patients it's around 0.97. So we will be attaching our Kaggle trained model against the GitHub code set as one of the URL in it, so that and even the confusion matrix and also the support and precisions. So as I said, the model was done on a pre-trained ResNet 50. So I think because the limited extents of time, we have used the ResNet 50, which was a pre-trained model built on around 10,000 classes of real-time data sets. But since we have a less amount of data, we couldn't create a custom made neural network. So once we have a ready good amount of data set, we can predict it out. But what we can say, this is not a production ready diagnostic way, because we really doesn't know how exactly different kinds of images are till date, because we do not have a real data set available. So this is our prototype to predict the COVID-19 or not. Thank you.